The 2002 National Electrical Code change, now Section 314.28, requires that wireways connected to equipment be sized to facilitate the future installation or replacement of conductors. This means the wireway must be large enough to accommodate the feeders and any future conductors that may need to be installed. The exact size of the wireway isn't explicitly defined in the National Electrical Code, but it mandates sufficient space for the existing feeders and potential future conductors. The specific dimensions of the wireway will depend on several factors, namely the quantity and size of the feeders, as well as the anticipated number and size of any additional conductors that might be installed later. Considering a scenario with two 3-inch rigid non-metallic conduits, often referred to as RNC, that terminate in the bottom of the wireway, the code necessitates a wireway with minimum dimensions of 6 inches wide by 6 inches deep. This configuration provides enough room for both the existing feeders and any prospective conductors introduced in the future. To reiterate, this requirement ensures easy accessibility and maneuverability of conductors within the wireway. This is essential not only for the initial installation but also for any subsequent maintenance, repairs, or upgrades to the electrical system. Now, let's delve into the calculations involved in determining the appropriate wireway size. We have a feeder conduit size of 3 inches. The feeder count is 2. This information is crucial for calculating the total feeder area. The formula for the total feeder area is 2 multiplied by the square of the feeder conduit size. In this case, that's 2 multiplied by 3 inches squared, which equals 18 square inches. Next, we need to consider the pull factor. For a pull of 12 feet or less, the pull factor is 6. This factor accounts for the space required to effectively pull the conductors through the wireway during installation or replacement. To determine the required wireway cross-sectional area, we multiply the total feeder area by the pull factor. In this example, that's 18 square inches multiplied by 6, resulting in 108 square inches. With the required cross-sectional area established, we can determine the wireway dimensions. A wireway with dimensions of 6 inches in width and 18 inches in depth would provide the necessary 108 square inches of cross-sectional area. However, it's crucial to remember that wireway dimensions are typically manufactured in standard sizes. Therefore, it's necessary to increase the calculated dimensions to the next available standard size. In this case, the next standard size that meets or exceeds the required cross-sectional area would be 8 inches in width and 18 inches in depth. This adjustment ensures compliance with industry standards and provides ample space within the wireway. Remember, these calculations are based on specific information provided in the prompt, including the number and size of the feeder conduits and the pull length. If any of these factors change, the calculations and required wireway dimensions will need to be adjusted accordingly. It's always best to consult with a qualified electrician or electrical engineer to ensure that the wireway is properly sized and installed in accordance with all applicable codes and regulations. The National Electrical Code is a comprehensive set of standards designed to ensure the safe installation and operation of electrical systems. Adhering to these standards is not only a matter of compliance but also a critical safety measure to protect people and property from electrical hazards. In summary, to correctly size a wireway, 1. Determine the size and number of feeder conduits entering the wireway. 2. Calculate the total feeder area. 3. Identify the appropriate pull factor based on the pull length. 4. Multiply the total feeder area by the pull factor to obtain the required wireway cross-sectional area. 5. Select a wireway with dimensions that meet or exceed the calculated cross-sectional area, ensuring that you choose the next standard size available. By following these steps and consulting with qualified professionals, one can ensure that the wireway is adequately sized to accommodate current and future conductors, promoting safety and facilitating future maintenance and upgrades to the electrical system. Always refer to the latest edition of the National Electrical Code for the most up-to-date requirements and guidelines. Code requirements can change from edition to edition, so it is essential to stay informed about the latest regulations. This ensures that any electrical installation complies with the most current safety standards. The proper sizing of wireways and pull boxes contributes significantly to the overall safety and reliability of electrical systems. Adequate space within these enclosures allows for proper heat dissipation, reducing the risk of overheating and potential fire hazards. It also facilitates easier and safer conductor installation and maintenance, minimizing the risk of damage to the conductors and reducing the likelihood of electrical faults. Beyond safety, properly sized wireways also improve the long-term performance and reliability of electrical systems. By providing sufficient space for conductors, they minimize stress and strain on the conductors and connections, which can lead to premature failure. This can result in reduced maintenance costs, fewer service interruptions, and a longer lifespan for the electrical system. In addition to the general requirements for wireway sizing, there are also specific requirements for certain types of installations. For example, in hazardous locations such as those where flammable gases or vapors may be present, wireways must be specifically designed and rated for use in such environments. These wireways are typically constructed of explosion-proof materials and have special seals to prevent the entry of flammable substances. Similarly, in corrosive environments, wireways must be made of materials that are resistant to corrosion, such as stainless steel or fiberglass. These materials protect the conductors and other electrical components from damage caused by corrosive substances, ensuring the long-term reliability of the electrical system. When selecting a wireway, it's also essential to consider the environmental conditions in which it will be installed. Factors such as temperature, humidity, and exposure to sunlight can all affect the performance and lifespan of the wireway. For example, in high-temperature environments, it's necessary to select a wireway that is rated for the maximum operating temperature of the conductors. This prevents the wireway from overheating and potentially causing damage to the conductors. In humid environments, it's important to select a wireway that is resistant to moisture and corrosion. This prevents the wireway from rusting or corroding, which can compromise its structural integrity and lead to electrical faults. Exposure to sunlight can also degrade certain types of wireway materials, so it's important to select a wireway that is UV resistant if it will be installed in direct sunlight. In addition to the material and construction of the wireway, it's also important to consider the method of installation. Wireways must be properly supported and secured to prevent them from sagging or moving. This can be achieved using a variety of mounting hardware, such as brackets, clamps, and straps. The specific type of mounting hardware required will depend on the size and weight of the wireway, as well as the type of surface to which it is being mounted. It's also important to ensure that the wireway is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The grounding conductor must be properly sized and connected to the wireway in accordance with the National Electrical Code. When working with electrical systems, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. It also includes energizing the circuit before working on it and verifying that the circuit is de-energized using a voltage tester. Never work on live electrical circuits unless you are specifically trained and authorized to do so. Electricity can be dangerous, and even a small shock can be fatal. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work for you. In conclusion, proper wireway sizing is a critical aspect of electrical system design and installation. By following the requirements of the National Electrical Code and considering the specific needs of the installation, you can ensure that the wireway is adequately sized to accommodate current and future conductors, promoting safety, reliability, and long-term performance. Remember to always consult with qualified professionals and follow safe work practices when working with electrical systems.